Hello everyone, we are working on problem number 15 in your homework packet. It says to find the equivalent resistance of the circuit shown in the figure. So I went on ahead and filled in a couple of values for our resistors. R1 is 200 ohms, R2 is 100 ohms, R3 is 70 ohms, R4 is 120 ohms, and R5 is 110 ohms. So I'm actually going to do this as a series of videos where not only in this first video are we going to find the equivalent resistance of this whole setup, which is the first thing that you want to do with any problem, but later on we're going to go look at the things like voltage drops, the current through the different resistors, the power, etc. So that we'll understand this circuit inside and out. It's got features that you'll see from everything, series, parallel, etc. So I think it'll be a real good prep. Anyway, so I've got this beautiful drawing of our circuit over here right now. And the first thing we want to look at is, this is our battery right here, so I'll put a V for voltage source. And we're going to have some electrons flowing around the circuit, and we want to first identify where we have a series and where we have parallel. So we'll just start moving through this circuit along here. So as the electrons are moving along, they all have to go through this 200 ohm resistor, okay? So we'll move through here. But then they reach a junction. Some of them will decide to go through here, this 110 ohm resistor, or some will decide to go through the 100 and the 70 ohm. Now you know about adding resistors up in series, and you know that this branch through here is going to be 110 ohms of resistance, and this branch through here is going to be 170 ohms of resistance. So maybe there will be a little bit more current going through here, this 110 ohm arm, than through this 170 ohm arm. Nevertheless, 100 and 70, those are both in series with each other, and then whatever that equivalent resistance is, that is in parallel with the 110 ohm resistor. We'll get to that soon enough. Nevertheless, the current divides up along these two different branches, only to meet back up right here again, and then move back through the circuit. All the current goes through the 120 ohm resistor, just as much as went through the 200 ohm resistor, and then we are back at the battery. Okay, so let's go now to finding out the equivalent resistance of the circuit. The first one that we're going to recognize is the 100 and the 70 ohm resistors. Those are in series with each other. Those we can collapse together into one 170 ohm resistor. It would be really hard to start with the 200 or the 110 or the 120. You really can't make a good statement about what the relationship is between those two. So let's go to our new slide here. And we will draw another one. So again, at the voltage source, we have yet to touch this resistor. It splits off. Into 2 right here. So we can go and label our values. Again, this stays as 200. This one is still 110. This one is still 120. But we collapse those two on the outside to 170. If you're wondering where I'm getting that from, that represents 100 plus 70 ohms. So when they say equivalent resistance, we're saying, well, you could have a 100 and then a 70 ohm resistor in series, or you could just get rid of both of those and just plop in one 170 ohm resistor. Okay, so now we're looking at this circuit again, thinking in the same terms as last time. We have some electrons coming out of the battery. It has to go through that 200 ohm resistor, and then now it splits between 110 ohms or 170. So we see that these two, 100 and 170, are in parallel with each other. This current comes back together, meets up, and completes the circuit. All right, let's see now. If you recall, our equation for equivalent resistance in parallel is a little bit trickier. In series, the equivalent was just simply R1 plus R2 plus, and on and on and on. The one for parallel is a little bit different. So we'll say that 1 over R in parallel is equal to 1 over R1 plus 1 over R2, and on and on and on. So redrawing our circuit, again with the same 12 volts, our 200 ohm hasn't changed, but now we collapse those two, the 110 and the 170 ohm together, and now we've got what looks like a nice series circuit. So this down here will be 120, and this right here, well, that's going to be 1 over Rp, which equals 1 over 110 plus 1 over 170. Plugging that into your calculator and solving for Rp, don't forget to invert that right there. That's 1 over Rp. That's not just Rp. That's a very common mistake that people make. You might have seen that mistake made when we were studying optics with that equation 1 over SO plus 1 over SI equals 1 over F. So 1 over Rp, that will equal approximately 66.8 ohms. Now it's almost trivial. We have a 200 ohm resistor in series with a 66.8 ohm resistor and a 120 ohm resistor. If you're following along, you know that we've got one last step. So lastly, we have our 12 volts, and all those three resistors being in series add up to one final resistor. This thing, our series, equals 200 plus 120 plus 66.8. So this is just like saying we can remove all the other resistors from our circuit and replace it with one 386.8 ohm resistor, and we'd have the exact same resistance. All right, in our next videos, we'll be looking at the voltage drops, current, and power of this circuit with all the resistors.